So in the last video of this series, we seen how you can use batch normalization, and along with input data normalization, we can also use the concept of learning rate scheduler to speed up the training of your neural network. So in this video, I wanted to take you through how to implement those concepts, the concept of batch normalization and learning rate scheduler in Pytorch. So we are still working with the MNIST data set, and these are like the boilerplate code, which I will skip because we have gone through it multiple times. So we create batches of data. So this is how we can implement batch normalization while creating a class or the neural network class, right? So we have our first fully connected layer. Then after that fully connected layer, we are initializing a batch normalization, which is associated with the first fully connected layer. So similarly, we will have several other batch normalization layers for each of the fully connected layers, right? And here we are passing this 512, which is like the number of nodes which are present in that first fully connected layer, right? So, and for the second fully connected layer, the number of nodes are 256. So all this we are passing as an argument to the batch norm 1D function. So this is when we are working with tabular data, we generally use batch norm 1D, right? And we are also using dropout here. So you can see like first we are passing our input data to the fully connected layer. Then once we have the output of that, then we are using the batch normalization on the linear operation of my fully connected layer, right? So if you remember in the last video we talked, we use batch normalization taking the Z as input to the batch normalization, and that Z will be normalized, and that normalized value will be fed to the activation function for that particular layer. So this is where the activation function is used. And last, we are using a dropout layer, right? So for every layer, there are several operations which are going on. First, we are doing the linear operation. Then we are normalizing the data for that particular batch using batch normalization. Then we are using the ReLU as an activation function. And in the end, we are using a dropout uh, for uh, for the generalization or for the regularization purpose. So once we have that, we will initialize the model, then we will use the loss function and the optimizer. So the also we talked about learning rate scheduler in the last video, right? So this is where we are kind of introducing, we are creating a learning rate scheduler where we are passing the optimizer which we created previously here, like we used SGD as stochastic gradient descent optimizer, and that we are passing as a parameter to this model. So we are starting with a learning rate of 0.05, and as we are using a step learning rate, so for every step, like for the step size, right? So you'll see like we have a step size which is equals to 10. So for every 10 steps, we will reduce the learning rate by a factor of 0.1. So your previous learning rate will be multiplied with zero point 0.1, and your learning rate will get reduced after every 10 epochs, right? So this is where we create the scheduler, the learning rate scheduler. So there are several others learning rate scheduler which are present in PyTorch. So I have given the link here also. So using this link, you can explore what are the other types of learning rate scheduler is there. So another specific learning rate scheduler, which I just wanted to mention for you guys, that is reduce on plateau. So that is when we are monitoring our validation loss, and validation loss is not getting decreased for certain number of epochs. Then what we do is we reduce the learning rate, and we hope that by changing this learning rate, your validation loss will again start decreasing. So that is the concept which we can also use when training a neural network. So reduce on plateau. So that is another type of learning rate scheduler which which you can use while creating a neural network. Now, the extra step which we are doing here is we are doing a scheduler dot step. So when we are initializing the epoch, or we are starting an epoch, and we are before going into the data loader, we are taking a scheduler dot step. So It will keep track of the number of epochs, and once there is a 10 epochs, then it will take a step and it will reduce the learning rate. Right. So with this, we can do the training much more faster. So you can see the time which it took to complete this process was 10 minutes for in a CPU. So if you use a GPU and with this, all the concept of batch normalization and learning rate scheduler, you can speed up your training process much more in multifolds, right? So yeah, so in this short video, I just wanted to talk two things: how to implement batch normalization in the neural network architecture, how you can incorporate the batch normalization, and also the concept of learning rate scheduler and how you can use that in the training loop, right? So this is where we use the scheduler.step to incorporate the scheduler in the training process, right? So yeah, I hope you like this video. So if you haven't subscribed this channel, please subscribe and share this channel with your friends and colleagues. Thank you for your time. See you in the next video.